Organic Shorts.
Oh, yeah.
Hey folks, we're going to talk today about cycloalkanes for you. So cycloalkanes are a cyclo structure or a ring structure made of only carbons and hydrogens. As soon as the structure contains other elements other than carbon as the main one making up the ring, we no longer have a cycloalkane. Instead, we have other things. Now, what's worth noting is there is a structure that exists out there. It's called a benzene ring. It's very, very common in living organisms. It looks like this, where we have a ring structure, a cyclohexane, but we have double bonds at 3 separate locations. Those are very, very common in amino acids and in nature. We are not going to focus on those in this class because the naming of them gets a little bit more advanced. Here you can see a couple examples: cyclopropane, 3-carboned ring; cyclobutane, 4-carboned ring; cyclopentane, 5-carboned ring; cyclohexane, 6-carboned ring. You can see a bunch of different names there. As far as the naming rules are concerned, there's a couple rules we want to follow. We want to determine the parent chain. It's always the one that contains the most carbons, and most of the time, I'll show you one where it's not, but most of the time, it's the ring structure. We then want to number the substituents, or the functional groups as we've been saying, so that the numbers are as low as possible. If there is only one substituent on carbon 1, it does not require a number. When 2 or more functional groups are present, we number according to alphabetical order. We looked at that with methyl and ethyl. We number the substituents and place them in alphabetical order, and then we call cyclic hydrocarbons, they give them the prefix cyclo, and then the alkane ending. So we have a couple different examples here. We have this first example here. We have 2 options for this one. We have either 1 ethyl, 3 methyl cyclohexane. So looking at this name, we can see that we have the order arranged by E ethyl and M methyl. We have arranged by alphabetical order. We see that we have a cyclo, meaning we have a ring structure; hex, meaning we have 6 of those carbons; and ane, meaning we have all single bonded together. Now, where we see this ethyl group is we see the ethyl group taking place right here. We have a 2-carbon functional group, and then right here we have a 1-carbon functional group. Now, as far as why we don't start numbering up here, 1, 2, and then 3, 4, 5, 6, 7, it's so that the functional group, which is actually the cyclohexane, starts at carbon number 1. That's ultimately what we want. As we get advanced into alcohols, aldehydes, that can slightly be changed, and then I'll show you an example of that in this lesson. But we start carbon number 1 up here, and then we have 2 options. We can either number 1, 2, 3, 4, 5, as in the right example, or 1, 2, 3. And in this case, we do not want to use this right example. We end up with lower numbers with the 1 ethyl, 3 methyl cyclohexane. Another thing worth noting is we started the numbering at the ethyl. And the reason that we did that was so that the 1 ethyl was present. We could go 1, 2, 3, but again, we want that ethyl group to have the lowest number possible since it's a bigger functional group, and also since alphabetically we're going to be listing it first. We have another example here. What happens if we have 1 functional group? We don't actually need to give a number if we only have 1 functional group. So you can see here we have a propyl group. And so because we only have 1 functional group coming off of this 6-carboned ring, we don't need to give it a number. And so this will be propyl, cyclo. We have 6 carbons, so hex, and they're all single bonded, so ANE. So the name of this molecule would be propyl cyclohexane. Again, because it's coming off of carbon number 1, there's only 1 functional group. We do not need to assign a number to it. This is what happens if we have a carbon chain that is longer than a cycloalkane. So here we can see that we have a 3-carbon cyclo group. In this case, what they do is they call this the octane. So 1, 2, 3, 4, 5, 6, 7, 8. So we have an octane there. We have a 3-cyclopropyl, 4,4-dimethyl octane. So that's a really short video on how to do cycloalkanes. Hope that made sense to you, and we will talk to you later.